Quick question for everyone. In 1492, Columbus sailed the ocean blue. You know that, right? Of course, everyone knows that. But here's my question. Do you know that, or do you have knowledge of that? What's the difference? Stick with me for 15 minutes and you'll never look at education the same way again. So, let me ask you something about science. DNA has 4 bases: adenine, thymine, guanine, and cytosine. If you can repeat that, you know it. You can tell somebody else, you can pass it on, you can sound educated, but do you have knowledge? The test is, let me ask you some follow-up questions. 1, why are there 4 bases and not 3 or 5? 2, how were they discovered? 3, what experiments prove this? 4, why does adenine pair with thymine and guanine pairs with cytosine? 5, what would happen if they paired differently? 6, can you test this yourself? 7, what are the actual chemical structures? 8, how do hydrogen bonds work in base pairing? If you can't answer those questions, you don't have knowledge. You have memorized information, and there's a massive difference. The point is, knowing equals you can repeat information. Knowledge equals you can explain, test, defend, and derive information. Most people stop at knowing. They think that's education. It's not. It's memorization. And let me show you the actual levels. Level 1, information. Raw data, isolated fact. An example would be DNA has 4 bases. Status, you heard it somewhere. Level 2 is knowing. Can recall and repeat. Example, I know DNA has 4 bases. A, T, G, C. Adenine, thymine, guanine, and cytosine. Status, you memorized it, you can pass a test. Level 3 is understanding. Comprehend relationships and mechanisms. Example, A pairs with T through 2 hydrogen bonds, G pairs with C through 3 hydrogen bonds. The pairing is based on complementary chemical structures. Purines, A and G, pair with pyrimidines, T and C, for consistent helix width. Status, you understand how it works. Level 4, knowledge. You can derive, test, apply, and defend. Example, I understand why the pairing works. Chemical structure complementarity. How it was discovered. Chargaff's rules showing equal A and T and G and C ratios, combined with Franklin's X-ray crystallography revealing helix structure. What experiments proved it? Watson and Crick's model testing, and I could test it myself with proper equipment. I can explain why mutations occur when pairing goes wrong and predict their effect. Status, you have actual knowledge. You could defend this if challenged. You know the basis of the claim. And level 5 is wisdom. You know when and how to apply knowledge appropriately. Example, understanding the base pairing allows me to comprehend genetic disease mechanisms, evaluate CRISPR ethics, recognize when someone is misrepresenting genetics, and understand both the potential and limitations of gene therapy. Status, you can use knowledge wisely in context. The problem is, most education stops at level 2. You know things, but you don't have knowledge, and you definitely don't have wisdom. Everyone knows this. In 1492, Columbus sailed the ocean blue. Columbus discovered America. You learned it in school. You've heard it your entire life. You know it. But do you have knowledge? The test is, let me ask you some questions. 1, what is the primary source evidence that Columbus sailed in 1492? His personal journal? Where is the original? Who verified it? Contemporary records? Which ones? Who wrote them? Physical artifacts, chips, documents? Where are they? 2, how was this date established? Who determined 1492? What evidence did they use? When was this fact first recorded? 3, can you verify this independently? What physical evidence exists today that you can examine? Are there competing historical accounts? What would disprove this claim? 4, what are you actually basing this belief on? Textbooks? Who wrote them? What were their sources? Teachers? Where did they get the information? Common knowledge? How did it become common? And here's the uncomfortable truth. You probably can't answer all of those questions. You know Columbus sailed in 1492, but you have no knowledge of whether this actually occurred. Your belief is based on you were taught in school, that's authority. Everyone says it's true, that's consensus. It's in textbooks, written authority. It would be weird if it wasn't true, social pressure. None of those are evidence. Those are appeals to authority. Does this mean Columbus didn't sail? No, I'm not claiming that. I'm showing you that you don't actually know. You just believe because authority told you. That's not knowledge. That's faith in the education system. The pattern is that this applies to almost everything you were taught. George Washington crossing the Delaware. Do you have knowledge or just knowing? Lincoln freeing the slaves. Do you have knowledge or just knowing? Did he actually do it? Is he the one? Was it someone else? What about the moon landing in 1969? Do you have knowledge or just knowing? The World War II timeline. Do you have knowledge or just knowing? Most of history you know is just information you memorized from textbooks, written by people you never met, based on sources you never verified, that you accepted because you were told to. That's not knowledge, that's programming. And the metaphor is, imagine an ant walking along. Suddenly, a shadow appears behind it, a massive lion silhouette. The ant sees this shadow and thinks, I'm protected, I have a lion behind me, I'm invincible. The ant starts acting tough, confronting other ants, challenging anything in its path. I have the lion backing me up. But here's the truth, the lion is made of cardboard. It's a flat cutout, no substance, no power. But the ant doesn't know what cardboard is, doesn't understand a shadow, so it feels completely safe. It thinks it has real protection. If that ant only knew that the lion was cardboard, its confidence would collapse instantly. And sometimes you are that ant. The lion behind you equals science, education, what everyone knows. You act confident because you think science backs you up. Education taught you. Smart people verified this. Everyone believes it. But that lion is cardboard. It's just information you memorized, not knowledge. Claims you never tested, not verification. Authority you trusted, not evidence. Consensus you accepted, not proof. And when someone challenges you, actually, can you explain how that works? What's the evidence for that claim? Have you tested this yourself? What experiments prove this? Your cardboard lion collapses because you don't have knowledge. You have knowing, and knowing without knowledge is just belief in authority. And let me show you how this applies to things that everyone knows. Example 1, the Earth is a spinning globe. Level 2, knowing. The Earth is a spinning globe at 1,000 miles an hour, orbiting the Sun at 67,000 miles an hour. But test for knowledge. 1, what is the expected curvature drop? Can you calculate it? 8 inches per mile squared. 2, why doesn't Polaris change angle despite Earth supposedly tilting 47 degrees on its axis? How does the heliocentric model explain this? 3, how was Earth's spin speed measured? What experiment detected 1,000 miles per hour rotation? Can you name that device that measures this? 4, what would falsify the globe model? What observation would prove it wrong? Are there any such observations? 5, can you defend the model when challenged? Long-distance photography shows objects that should be hidden by curvature. How does refraction account for 443 kilometers of visibility at eye level? Most people fail these questions. They know Earth is a globe, but they have no knowledge of the basis for that claim. They have a cardboard lion. Example 2, the moon reflects sunlight. Level 2, knowing. The moon reflects light from the sun. Why it glows at night? But test for knowledge. 1, what experiments tested whether moonlight is reflected sunlight? Can you name them? What were the results? 2, why does moonlight have a cooling effect? If it's the same light, just weaker, why opposite thermal properties? How does the reflection model explain this? 3, can you test it yourself? 2 thermometers, 1 in moonlight, 1 in the moon shadow. Which reads cooler? Answer, moonlight is cooler than the moon shadow. So how does the reflection model explain this? 4, why do biological effects differ? Why does moonlight affect sleep, mood, menstrual cycles differently than sunlight? If it's the same light, why different biological response? Again, most people fail. They know moon reflects sunlight, but they have no knowledge of whether this is actually true. It's a cardboard lion. Example 3, gravity holds everything down. Level 2, knowing. Gravity is a force that attracts mass, that's why things fall. But test for knowledge. 1, what is the mechanism of gravity? How does mass attract other mass? What is actually happening at the particle level? 2, has gravity ever been directly observed? Can you name an experiment that detected gravitational force? Or do we just observe falling and assume gravity? 3, why does gravity fail at the quantum scale? Quantum mechanics and general relativity are incompatible. Why does gravity not work in the quantum realm? 4, could electromagnetic force explain the same observations? Electromagnetism is 10 to the 39 times stronger than gravity. Could falling be electromagnetic, not gravitational? Have you investigated this alternative? People know gravity is real, but they have no knowledge of the actual mechanism. They can't defend it when challenged, because the lion is cardboard. It's a dangerous illusion. When you have knowing without knowledge, you think you're educated, but you just memorized. You think you're protected by science, but you never verified. You act confident, false confidence from cardboard lion. You dismiss challenges because everyone knows. You call questioners ignorant while being unable to defend your own position. But when someone asks you to explain, you can't. You fall back on, that's what scientists say. You fall back on, it's in textbooks. You fall back on, everyone knows that. You get defensive and angry because your cardboard lion just collapsed. The difference is a person with knowing, the Columbus sailed in 1492, everyone knows that, it's in all history books. And then the person with knowledge, the claim is that Columbus sailed in 1492. The earliest records of this claim come from X source. The physical evidence includes these artifacts. Competing theories suggest these alternatives. Based on my investigation of primary sources, I believe a conclusion with reasoning. See the difference? Big difference. One is repeating information, and one is demonstrating understanding and investigation. Only one is actual knowledge. And here's how to test if you have knowledge versus just knowing. Apply these 8 questions to any claim you believe. 1, why is this true? Not who said it's true, but what is the mechanism? The example is, why does the moon glow? Knowing, it reflects sun. Just repeating. Knowledge, the reflection model predicts identical properties to sunlight, but observations show opposite thermal effects. The electromagnetic complementary model better explains cooling effect and biological differences. 2, how was this discovered? What experiments led to this conclusion? Example, how do we know Earth is spinning? Knowing, scientists proved it. Appeal to authority. Knowledge, the Foucault pendulum is cited, but it demonstrates rotation of pendulum relative to background stars, not Earth rotation. The Michelson-Morley experiment expected to detect Earth's motion through ether, but found no movement, leading to relativity theory as explanation. 3, what evidence supports it? Can you cite specific tests with results? Example, what evidence supports heliocentrism? Knowing would be planets orbit the sun. Everyone knows that. That's consensus. Knowledge is the heliocentric model requires constant corrections, retrograde motion, ecliptic anomalies, precession, etc. Geocentric models with electromagnetic mechanics can explain the same observations without requiring motion we can't detect. 4, can I test it myself? Is it falsifiable and repeatable? Example, can I test Earth's curvature? Knowing is scientists already tested it. That's trust. Knowledge is using a theodolite and laser over water, I can measure expected versus observed drop. At 10 miles, the expected curvature drop is 66.69 feet. Long distance observations show objects at eye level that should be hidden. This is testable, repeatable, and challenges the model. 5, what would disprove it? What observations would break the model? Example, what would disprove the spinning globe? Knowing is nothing. It's a proven fact. Unfalsifiable, not science. Knowledge is, if Polaris maintained constant angle despite Earth's supposed 47-degree tilt, that would falsify the model. If long-distance photography showed no curvature drop, that would falsify it. If stellar parallax didn't match predicted values, that would falsify it. These observations exist and require explanation. 6. Can I defend it when challenged? Do I understand it or just repeat it? Example, explain why water stays on a spinning globe. Knowing is gravity holds it, circular reasoning, gravity is what we're questioning. Knowledge is the mainstream model requires that gravitational force, 10 to the 39th power times weaker than electromagnetic force, overcomes centrifugal force from 1,000 mile per hour spin. The math shows centrifugal force at equator should be 0.3% of gravitational force, keeping water adhered. However, this assumes gravity exists as described. Electromagnetic models propose water's polarity responds to Earth's electromagnetic field, explaining adhesion without requiring undetected gravity mechanisms. 7. What are the assumptions? What must be true for this claim to work? Example, Columbus sailed in 1492. Knowing is, it's in history books. That assumes textbooks are infallible. Knowledge is, this assumes 1. Surviving documents are authentic. 2. Translation is accurate. 3. Dates weren't altered during calendar reforms. 4. No political motivation to fabricate. 5. Physical evidence corroborates timeline. Each assumption requires separate verification. And 8. Have I verified it personally? Or did I just trust authority? Example, DNA has 4 bases. Knowing is, my teacher said so. Authority. Knowledge is, I've examined the published research on Chargaff's rules, viewed electron microscopy images, studied the chemical structures of purines and pyrimidines, and understand why Watson-Crick base pairing produces consistent helix structures. While I haven't personally isolated DNA, I comprehend the experimental basis and could replicate with proper equipment. Now, apply this test to everything you think you know. Science claims vaccines prevent disease. Knowledge or knowing? Evolution explains biodiversity. Knowledge or knowing? Big Bang created the universe. Knowledge or knowing? Atoms are mostly empty space. Knowledge or knowing? Historical claims Hitler started World War II. Knowledge or knowing? JFK was killed by Oswald. Knowledge or knowing? 9/11 was done by terrorists. Knowledge or knowing? Slavery ended in 1865. Knowledge or knowing? And medical claims. Cholesterol causes heart disease. Is it knowledge or knowing? Fluoride prevents cavities. Knowledge or knowing? Chemotherapy cures cancer. Knowledge or knowing? Viruses cause illness. Is it knowledge or knowing? We have political claims. Democracy is best for government. Capitalism creates prosperity. Taxes fund government services. Elections are fair. Knowledge or knowing? For each one, ask, why is this true? How was this discovered? What evidence supports it? Can I test it myself? What would disprove it? Can I defend it when challenged? What are the assumptions? Have I verified it personally? If you can't answer most of these, then you don't have knowledge. You have a belief based on authority. You have a cardboard lion. This is why schools teach knowing instead of knowledge. The education system is designed to create people who can repeat information, useful workers, people who trust authority, obedient citizens, people who don't question fundamentals, stable system, people who mock questioners, self-policing population. Not people who test claims independently, question foundational assumptions, demand evidence before believing, think critically about authority. And the method is, step 1, teach information as unquestionable fact. Columbus sailed in 1492. Don't ask me how we know, just memorize it for the test. Step 2, reward memorization. Punish questioning. Good grades for repeating. Bad grades for challenging the curriculum. Step 3, associate questioning with stupidity. Everyone knows that. Are you stupid? Did you just learn what you're taught? Step 4, create social pressure to conform. You sound like a conspiracy theorist. Just believe what scientists say. Step 5, graduate confident people with cardboard lions. I'm educated, I went to college, I know things, But they don't have knowledge. They have expensive memorization. The result, is millions of people, or billions, who think they're educated when they're programmed, mock questioners defending their programming, can't defend their beliefs, no actual knowledge, get angry when challenged, cognitive dissonance, have false confidence, cardboard lions. This is by design. Actual knowledge is dangerous to authority. Knowing without knowledge is perfect for control. So, how do you move from knowing to knowledge? Well, step one is question everything you were taught. Not to reject it all, but to test it all. Pick one thing you know and ask, how do I actually know this? What's my evidence? Did I verify it or just accept it? An example would be, Earth is a globe. What's my basis for believing this? Did I test it or did someone tell me? If challenged, could I defend it or would I just appeal to authority? Step two, seek primary sources. Don't just read textbooks, find the original research. For Columbus, don't read in 1492 Columbus sailed in a textbook, find his actual journal. If it exists, find contemporary records. Who wrote them? Examine physical evidence, ships, artifacts, documents. Read competing accounts, then form your conclusion. For science claims, don't just trust scientists say. Read the actual published papers, examine the methodology, check for conflicts of interest, look for replication studies, then form your conclusion. Step 3, test claims independently. If something is true, it should be testable by you. An example would be moonlight cooling. 2 thermometers, one in the moonlight, one in the shadow. Full moon night, clear sky, measure it after 30 minutes. Result, moonlight is cooler than moon shade. So you just tested a claim yourself. Earth curvature, calculate expected drop, 8 inches per mile squared. Find long distance view over water. Use theodolite or strong camera. Measure observable versus predicted. You just tested a claim yourself. Water finds level. Large container of water. Add dye for visibility. Observe the surface. Does it curve or level? You just tested a claim yourself. Knowledge comes from doing, not reading. Step 4 is learn to say, I don't know. That's the most important step. Stop pretending to know things you don't. It's okay to say, I was taught that, but I've never verified it myself. I believe that, but I can't defend it when challenged. I know the claim, but I don't understand the mechanism. I accepted that on authority, but I should probably test it. Intellectual honesty is more impressive than false confidence. Saying, I don't know, is stronger than defending cardboard lions. Step 5, pursue actual understanding. Move up the hierarchy from knowing, DNA has 4 bases, to understanding, A pairs with T through 2 hydrogen bonds, G pairs with C through 3 hydrogen bonds. The complementary chemical structures ensure consistent helix width. To knowledge, I understand the chemical basis for base pairing. The experimental history of its discovery, the implications for genetic inheritance, and could test complementary principles with proper equipment. To wisdom, this understanding allows me to evaluate genetic engineering claims, recognize oversimplifications in media, and make informed decisions about genetic technologies. That's education, not just memorizing for tests. So here's where we are. You've spent your whole life thinking you're educated. To know things. You know things. You learn them in school. Everyone agrees. It's in textbooks. But you have a cardboard lion. I have many cardboard lions, and I'm trying to get rid of them all. And when challenged, you have to accept that you can't explain the mechanisms. You can't cite original research. You can't defend against observations. You fall back on everyone knows and scientists say. That's not knowledge. You have to get away from that. That's how I started to actually learn and actually gain knowledge and wisdom. You don't want programming disguised as education, but there's good news. You can change this starting right now. Pick one thing you know. Columbus sailed in 1492. Earth is a spinning ball. Moon reflects sunlight. Vaccines prevent disease. Evolution is a proven fact. Gravity holds us down. Apply the 8 questions. Why is this true? How was this discovered? What evidence supports it? Can I test it myself? What would disprove it? Can I defend it when challenged? What are the assumptions? Have I verified it personally? Be honest with yourself. If you can't answer most of these, you don't have knowledge. You have knowing, and that's okay. It's time to find the difference. That's how you gain wisdom. Because the cardboard lion can't protect you. Only actual knowledge and wisdom can. So welcome to Real Education.